Okay, in this video, we want to prove this theorem. We want to prove that a bounded function is Riemann integrable if and only if it is Darboux integrable. And in this case, the Riemann integral is equal to the Darboux integral. All right, so let's look at the case. We're going to prove, this is a bidirectional thing here. So first, assume f is Darboux integrable. Okay, let's assume f is Darboux integrable. Then there exists then for all epsilon, there exists a delta such that if the mesh of P is less than delta, then U of Fp minus L of Fp is less than epsilon. Okay, so we're going to use this fact to prove that F is Riemann integrable. So let me just point out something. If P is any partition, then we have the following inequalities. L of Fp is less than or equal to S of Fp, and this is less than or equal to U of Fp. Okay, so I need to say something about this. On the left-hand side and the right-hand side, P is just a partition, and we're taking the lower Darboux sum and the upper Darboux sum. In the middle here, we need to interpret P as being a tagged partition. And so what I'm saying is, if we fix a partition P, then these two inequalities hold no matter what the tags are. Because what's happening for the lower sum? Well, for each subinterval, we're looking at the infimum of f over that subinterval. And for the tagged partition, if for any tag, we're just looking at f evaluated at that tag, at that xk star. And so the infimum of f over the subinterval is going to be less than or equal to f of xk star. Okay, so that's what we have. We're going to use this and some other stuff. So I'm going to look at if P is any partition with mesh size, if it's any tagged partition with mesh size less than delta, I'm going to look at S of Fp minus U of f. So remember, U of f is equal to L of f, so U of f is equal to the Darboux integral. So by the triangle inequality, this is less than or equal to S of Fp minus L of Fp. And again, here I'm thinking about P as being any tagged partition, and then L of Fp is just the lower Darboux sum. And then this is plus U of f minus L of Fp. Okay, now I need to do something here. I want to get rid of these absolute value signs. So notice that S of Fp, by this inequality, S of Fp is always greater than or equal to L of Fp. So I can just write this as S of Fp minus L of Fp. You'll see why we want to do that in a second. Over here, notice that U of f is an upper bound for L of Fp. This is something that we showed in the previous video, that if I have any partition, if I have a partition P and a partition Q, then L of Fq is less than or equal to U of Fp. And so this means that the upper Darboux integral is an upper bound for all of the L of Fp's. We did this on Monday or something. We proved this on Monday, that U of f is an upper bound for the lower Darboux sums, and L of f is a lower bound for the upper Darboux sums. In either case, U of f is greater than or equal to L of Fp. So this is equal to U of f minus L of Fp. Okay, so now notice that S of Fp, again, by this inequality, is less than or equal to U of Fp. So this is less than or equal to U of Fp minus L of Fp. And U of f is the lower bound, it's the infimum of all of the U of Fp's. So U of Fp is also less than or equal to U of f, or U of f is less than or equal to U of Fp for any partition, in particular the one that we're interested in. And now this is just equal to 2 times U of Fp minus L of Fp. But U of Fp minus L of Fp is less than epsilon, so this is less than 2 epsilon. So in other words, for any epsilon, we've shown that S of Fp minus U of f is less than 2 epsilon. Okay, so if f is Darboux integrable, S of fp minus U of f is less than 2 epsilon. In other words, S of fp is equal to U of f. U of f is the Darboux integral of f. So this tells us not only is f Riemann integrable, but the Riemann integral is equal to the Darboux integral. So what we've proven here is that if f is Darboux integrable, then it is Riemann integrable, and the two integrals are equal. So now let's prove the other one. Let's assume now that f is Riemann integrable. So let's assume f is Riemann integrable. Assume f is Riemann integrable. Let epsilon be greater than 0. And let delta be from the definition of Riemann integrability. So in other words, if P is any tagged partition with mesh size less than delta, then we know S of Fp minus the Riemann integral of F is less than epsilon. Okay, so now what we want to do, we're going to okay, so we need to find a partition so that U of Fp minus L of Fp is less than epsilon. That's what we want to do. Okay, so let P be a partition. We're going to use, in other words, I want to use a theorem from like the first video in this lecture that says if U of Fp minus L of Fp is less, if you can find a partition where U of Fp minus L of Fp is less than epsilon, then the function is Darboux integrable. Okay, so let P be any partition with mesh size, with the mesh size of P being less than delta. And now I want to choose, so Riemann integrability says that this is less than epsilon no matter what my sample points are. So I want to pick cleverly chosen sample points. So I want xk upper star, or sorry, I want xk star. I want my sample points to satisfy f of xk star is less than the minimum or the infimum of f over the set xk to xk plus 1 plus epsilon. So this is the infimum of f over the interval. Xk star is in the interval, so I can always find some xk star where f of xk star is less than the infimum plus epsilon. Okay, and then these are the tags for the partition, the tagged partition that I'm going to call P lower star. Then what I know is f of Fp lower star, this is going to be equal to the sum f of xk star times, I realize I got my index wrong here a little bit. This should be k minus 1 to keep things consistent with how I do it. So this will be k equals 1 to n xk minus xk minus 1. But f of xk star is less than m plus epsilon. So this, I will let you think through this. If I replace this with this plus epsilon, this is just going to be L of Fp plus epsilon times B minus A. Okay, now similarly, if I say xk star, I want to pick tags xk star that satisfy f of xk star is greater than the supremum of f minus epsilon, then a similar argument shows that f of Fp upper star is greater than U of Fp, is greater than the upper Darboux sum on that partition minus epsilon times B minus A. Pause the video and think through this. specifically this inequality here. Again, I'm using the fact that f of x k star is less than that. So if you just replace f of x k star with that, then I think you should be able to get that. I mean, you will be able to get that, but I mean, I think that you should be able to figure out how to get that. And then now I'm just applying a very similar argument here that I did here. Okay, so altogether, what this tells me is S of f p lower star minus S of f p upper star. This is less than or equal to S of f p lower star minus L of f. Sorry, not minus L of f. Minus the, I'm just going to use the letter I to denote the Riemann integral of f, plus S of f p upper star minus I. And now I know that this well, P star is any tagged partition. P upper star is any tagged partition. So by the definition of Riemann integrability, this is less than epsilon and that's less than epsilon. So altogether, this is less than 2 epsilon. So putting these three inequalities together, these three inequalities, meaning this inequality, and this inequality, I have the following estimate. I have U of fp is less than S of fp star. This, sorry, S of fp star, yeah, S of fp star plus epsilon times b minus a. This is less than S of fp lower star plus 2 epsilon plus epsilon b minus a. And this is less than or equal to L of fp. Again, it's going to be plus 2 epsilon and then plus another epsilon b minus a. So plus 2 epsilon times b minus a. Okay, so in other words, U of fp is less than L of fp plus 2 epsilon times b minus a. Now, b minus a is fixed, so I can make this side as small as I want by picking different partitions. So in other words, I've proven the Riemann or the Cauchy criterion that U of fp is less than L of fp plus epsilon. And so that shows that if the function is Riemann integrable, then it's Darboux integrable. And we saw in the last video that if it's Darboux integrable, then it's Riemann integrable, and the two integrals are the same. So this proves the whole theorem that I have claimed.